fluid pressure. If we want to define fluid pressure, then it is simply the difference between gauge pressure and atmospheric pressure. So, the gauge pressure is equal to total pressure minus PA atmospheric pressure. Some concept about absolute and gauge pressure. Pressure measurement are generally indicated as being either absolute or gauge pressure. It may be absolute pressure or gauge pressure. Gauge pressure, it is the pressure measured above or below the atmospheric pressure, that is taking the atmospheric as the base or the reference point. It can be negative or positive. If the pressure of the gas is above the atmospheric pressure, then the gauge pressure is positive. If there is some vacuum, then gauge pressure is negative. So, the negative gauge pressure, it also known as vacuum pressure. Next term comes absolute pressure. It uses absolute zero, which is the lowest possible pressure. If there is no gas, no atmospheric pressure, then the zero absolute pressure is there. So, that is the lowest possible pressure, and absolute pressure will always be positive. It can neither be negative, because absolute pressure is starting from 0, it is not starting from negative, and absolute pressure is equal to gauge pressure plus atmospheric pressure. P absolute is equal to gauge pressure P gauge plus P atmospheric. Next, we find the relation between gauge pressure and absolute pressure. We know absolute pressure, it is the sum of gauge pressure plus atmospheric pressure. So, here the gauge pressure is 30 psi and atmospheric pressure we will take 15. So, 14.7. So, the total pressure of the body becomes 30 plus 14.7, that is 45 approximately, 45 psi. Next, we find some numericals related to this, all these. Now, we will express a pressure of 155 kilopascal as an absolute pressure. Then we will express a pressure this as an absolute pressure, where the local atmospheric pressure is 101 kilopascal. We know absolute pressure is equal to gauge pressure plus atmospheric pressure. Gauge pressure is 155 and atmospheric pressure is 101 kilopascal. So, for the first part, for this part, the pressure becomes 155 plus 101 is equal to 256 kilopascal. And for the second part, if we define this, for this absolute pressure, it is gauge pressure minus atmospheric. Gauge pressure is minus 31 and atmospheric pressure is 101. So, absolute pressure is minus 31 plus 101 is 70 kilopascal. Next, we will find the pressure based upon this formula rho gh. What will be the gauge pressure? First, we have defined gauge pressure and absolute pressure of the water at the depth of 12 meter below the surface. Here the depth is 12 meter and a row of water, density of the water is 1000 kilogram per meter cube and atmospheric pressure is 101 kilo Newton per square meter. So, gauge pressure is rho into G into H, rho water density is 1000 and gravitational due to acceleration due to gravity is 9.81 and height is 12 meter. So, pressure is rho into G into H, it comes out to be 117.7 kilo Newton per square meter, that is kilopascal. So, absolute pressure is equal to gauge pressure plus atmospheric pressure. Gauge pressure is 117.7 plus atmospheric pressure is 101. So the total absolute pressure is 218.7 kilogram Newton per square meter, that is kilopascal. Next again there is some numerical related to this. A cylinder contains a fluid at a gauge pressure of 200 kilo Newton per square meter. We have to define this pressure in terms of the density of the water, in terms of height of the mercury. So for the water, H is equal to P upon rho g, because P is equal to rho Hg. So height comes out to be P upon rho into g. Pressure is given to be 200 kilo Newton per square meter. So pressure is 200 into 10 raised power 3. Rho for the water is 1000. Rho for the water is 1000 into g is 9.81. So height is 20.39 meter of the water. If we take in a container a water, then height for this pressure is 20.39. But for the same, if we take same height, same this pressure, same gauge pressure, but different liquid, instead of water we will take mercury, then height becomes 1.5 meter. So mostly in barometer we will use mercury instead of water, because mercury has more density, so its height is less as compared to water case. Absolute pressure is defined as atmospheric plus gauge pressure. Atmospheric pressure is 101.3 and gauge pressure is 200. So the total pressure becomes 301.3 kilogram Newton per square meter. Next, the pressure measurement. Pressure measurement, they are called pressure gauge. A pressure gauge is used for measuring the pressure of a gas or a liquid. A vacuum gauge is used to measure the pressure in a vacuum. A compound gauge is used for measuring both vacuum and pressure, and pressure gauges are used for indication only, that is there is less pressure or more pressure, etc. Next, pressure gauge, they are used in many cases, like if we want to check the air in our tires, in the tires of the vehicle, so we can easily check with this indication, that is if there is perfect air in the tire or not. We can easily find out the blood pressure with this instrument. This mainly works on the principle of pressure. If pressure is more, so depending upon the pressure, this mercury rises in the these apparatus. First, pressure measurement is with the help of barometer. This is called mercury barometer. In this, the mercury is placed here. This is called vacuum. This is nearly perfect vacuum, there is no gas. The height to which this mercury rises, from this height we can easily find out the pressure of the atmospheric. This height is like 760 mm of mercury for the atmospheric pressure. We will define in detail here. Atmospheric pressure, it is usually measured by a mercury barometer. This is mercury barometer, because here the mercury is placed in this, mercury is used. A simple barometer, it consists of a tube more than 760 mm or 330 inch long. This tube is more than 760 mm and 30 inches. A void, this void is produced at the top of the tube, which is perfectly vacuum. There is no gas here, this is perfectly vacuum, and height is above the 760. So the mercury rises up to this point. This point is called, up to this point we can easily find out the atmospheric pressure. Approximately for the normal day, the atmospheric pressure is comes out to be 1 atmospheric, and it is corresponding to the 760 mm of this height. If we want to measure the height, then this comes out to be 76 centimeter, or we can define 760 mm. So, we can convert this height into pressure with this formula. P atmospheric is equal to rho into G into H. Rho is density, G is acceleration due to gravity, H is height. So, with the height, by putting the height here and the density of that liquid and acceleration due to gravity, we can change height into pressure. Next, some historical background about this instrument, about barometer. It is an instrument that is used to measure atmospheric pressure. It is invented in 1600 by E. Tresley, and height of the column of the mercury, it shows the atmospheric pressure. Above, up to which height it goes, then that is corresponding to the atmospheric pressure. So, atmospheric pressure in the mercury, this is mercury barometer. Here the mercury rises in this column. The atmospheric pressure is directly proportional to force applied on mercury. So, change in height, it depends upon the atmospheric pressure. If the atmospheric pressure is more, then height is more. If the atmospheric pressure is less, then height is less. Next device used to measure pressure is C-type Burden type. Here first, this is elliptical type. If we fill air, some gas here, so it becomes circle type, and this indication shows us the pressure. So, this is a tube, section of a tubing that is closed at one end and is partially flattened and coiled. When a pressure is applied to the open end, here if we apply a pressure, then the tube uncoils, and this movement provides a displacement that is proportional to applied pressure. So, we can easily find out the pressure with the help of this tube. Last type is manometer, to find out the pressure of the gas or fluid. So, mercury manometer is a simple pressure standard and may be used for the gauge, differential and absolute pressure measurement with a suitable reference. It is useful mainly for the lower pressure work because of height. So, in the manometer, this is U type tube. So, if the pressure is more at this side, so the liquid rise up to this height and vice versa. If the pressure is more at this point, then height will be more in opposite side. And this type of manometer, it is usually used in laboratories. It measures the difference in pressure between 2 points in the pipe. Here we completely define the U-tube manometer. One end of the U-tube is connected to a pressure. Here this is fluid for which we want to find the pressure. Its density is rho, and this liquid is called manometric liquid, and its density is rho, MAN, and this is called U-tube manometer. One end of the U-tube, it is connected to a pressure that is to be measured. So, it is connected to a pressure that is to be measured, and another end is left open. This end is open for the air. So, here the pressure exerted is atmospheric pressure. So, the tube contains a liquid which is called manometric fluid, and it does not mix with the fluid whose pressure is to be measured. The important point here is that the fluid whose pressure is measured should have a lesser density as compared to manometric fluid. So, based upon if there is no gas, then these two columns are equal, then the height of these two are equal, and if there is some gas in the container, then height changes depending upon the pressure. So these closed type and open type manometer, they are used for different purpose. A gas is placed in the flask attached to a closed manometer. The gas pressure pushes the mercury into the tube, so there is change in height, that is delta H here. Next, if we take open manometer instead of closed manometer, then if there is no pressure, then these two are equal. If the gas pressure is less, then there is increase in height in this direction, but if the atmospheric pressure is less as compared to gas pressure, then the height increases in this direction. So simple application of this barometer is that we cannot drink the soda through the straw unless atmospheric exert a pressure on the surrounding liquid. Thank you.